dungeon. Dark and scary. Oh no. But up here, it's good. He's like nice and high and you can see everybody. He's like, hey everybody. Okay? Alright, so don't be afraid of the answer 0. Sometimes people are like, I got 0. And I'm like, cool. Congratulations. Alright, so over here, we are going to distribute the 1/2. Okay, hopefully y'all aren't scared of fractions either, because you might see some.
Just a little.
We're going to subtract the 4. Okay, I get 0, and then divide by 1/2 or multiply by 2, and I still get 0. Okay, now in between here was an or. So I got 2 answers. I got x is less than 0 or x is greater than 0. Let's look at a number 9. Okay, so if I were to plot the points that are less than 0, that would be everything over here, right? Not including 0. Okay. If I were to plot the points that are greater than 0, that would be everything over here. Not including 0.
So it would just be infinite. It'd just be the entire number line?
Except for 0. Except for 0.
Whoa.
So it's everything over here or everything over here. So it actually winds up being the entire number line except 0. So instead of writing blah, 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 you're going to write x cannot equal 0. And x is all real numbers. This little guy is kind of like a C with a little line through it. It's a symbol in math. It means to belong to. Okay, so we use it for when we're referring to stuff being in sets. Okay, so this says x belongs to, and then this is the set of real numbers. So you guys know what real numbers are, right? What are real numbers?
The real
1.
through
Forevers. Pretty much every number that we deal with, right? Okay, all rational and all irrational numbers are real numbers. Okay, so it's just like a R with an extra line in it. It's called the set of real numbers. So this means x can be anything except 0.
Okay.
Now, if I changed this question so that one of these was like this, how would that change the question?
It would be everything.
It would be everything, right? Because it does actually include 0. Okay, questions? All right, let's look at that one. All right, so for this one, we have an and in between, so we're going to answer each one separately. We're going to put an and in between our answers at the end. So I can add x to the side, so I get 7 plus 2x is greater than or equal to 9. Subtract 7, so 2x is greater than or equal to 2, and then divide. I get x is greater than or equal to 1. So that's my solution set for the first inequality. I'm going to go to the other one. I can distribute and get 1/3 x plus 1 is less than or equal to 4/3. And then subtract 1, so what's 4/3 minus 1?
3.
1/3. 4/3 minus 1 is like 4/3 minus 3/3. And then divide by 1/3 or multiply by 3 and you get x is less than or equal to 1. And we have to say and in between these, so we're saying x is greater than or equal to 1 and x is less than or equal to 1. Here's 1. So I'm looking at all numbers greater than or equal to 1 and numbers less than or equal to 1. How many numbers is that?
All numbers.
all real numbers.
Are you sure? Look again. Greater than or equal to 1 and less than or equal to 1.
But not 1.
It's just 1. You're looking for the intersection of that blue and that pink line. So essentially, where is the purple? It's just on 1. Okay. The only overlap or intersection is 1. That's the only place where you see both solution sets overlapping or intersecting. Okay, so remember when I drew like the kind of like the Venn diagram, right? This is all the stuff greater than 1. This is all the stuff less than 1, this is 1, that's where they overlap. This is our answer, because it's and. We want the intersection. So instead of writing all of this, we're just gonna write x equals 1. It's a shorter way of writing our answer, a more concise and actual answer. Because saying this is like saying a bunch of stuff that isn't actually our answer. Our only answer here is 1. Okay, now if it said or, then you would have all real numbers. Okay, if sometimes the overlap will be kind of in a weird place. So let's look at a number line like 1 and like -1. So let's say our answer is x is greater than or equal to -1 and x is greater than or equal to 1. Where's the overlap? Yeah, 1 and beyond. So instead of saying both of these things, we can just say this one piece. Okay, because that's where they're overlapping. If it said or in between, what would our answer be? Greater than -1 or greater than 1?
0.
Great.
Which numbers are greater than -1 or greater than 1? All numbers greater than -1, right? If they're bigger than 1, they're going to be bigger than -1, right?
Mhm.
I don't need both of those things. I can just use this one. Okay. When you draw the graph, you can kind of see this a little bit better. You can like physically see the intersection, okay, and you can see the lines. So even if it doesn't say to graph your solution set, you should graph your solution set at the end to make sure that you're, giving either the most simplified answer or that you're including all the answers, okay? Because sometimes you might not notice that it's all real numbers unless you graph it and see, oh, look, I shaded everywhere. Or you might not see that it's no solution until you see, oh, look, there's no intersection or something like that, okay? So keep that in mind when you take your test/quiz and other things, when you do your math Excel, that there are special cases. Okay, questions? Yeah.
So if you use and, you usually have like one answer, so like x is equal to like a number, and then if you use or, is it usually you have an inequality as an answer?
Yeah, sometimes with and we have like these ones where they intersect in the middle, but then like with the exceptions, it could be like just that one value. Or it could just, like that last one I had up there, just kind of narrow it down from 2 things to 1 thing. It could be, so. Okay, so if it was like this, what numbers are less than -4 and greater than 4? Everything above 4? Has to be nothing.
Like,
Oh wait, yeah.
yeah, okay.
Yeah,
That
something
makes
like
sense,
that.
Yeah.
Because there's no intersection, those aren't intersecting ever. They're not going anywhere near each other, so you can't have solutions there. Okay, so we now are moving along to section 6. We are still going to be doing inequalities at the end. So we're going to start with absolute value equations and then move along to absolute value inequalities. So those are coming back. Does anyone have their vocab and know what the definition of an absolute value of a real number is? There's a few different definitions too.
Let's see, what can I look at first? A real number is distance from 0 and a number on line.
Okay, so the absolute value of a real number is its distance from 0. So if I said the absolute value of x is 5, what is x? What is x?
-5 is 5.
Yes, you have 2 possible options. You have -5 and you have 5, because both of those numbers are 5 away from 0 on a number line, right? So you got 2 things. in general, when you take absolute values of numbers, right, like you did this a long time ago, the absolute value of 5 is 5. The absolute value of -5 is also 5. So there's always going to be two things, with one exception. What number, when you take the absolute value of it, is only going to get one thing?
0 or?
0. Okay, so there's no like positive and negative 0. There's just 0. 0 isn't positive, it's not negative. He's just his own thing. So when you take the absolute value of 0, you get 0. So there is one number whose distance from 0 is only one thing.
So x would be 5, -5?
For that one, yeah. So it's important to see though that we got 2 answers. For most of these questions, you'll get 2 answers. Sometimes you'll get 1, like in the scenario that I was just saying. Sometimes there's 0 involved in the question. You can't be 2 distances from 0 if you're at 0. Okay, so sometimes you'll get 1 solution, and then occasionally you could get no solution. So what would have to be here in order for it to be no solution?
A negative on the inside?
Well, not necessarily, because if it's like 2,
Negative on
then
the
it
outside.
could be 2, it'd still be fine.
A negative on the outside.
Negative on the outside?
Yeah.
This is bad, right?
That is extremely bad.
This is bad. So if you have an absolute value and it's equal to some kind of negative number, we can't have that. We know that every time we absolute value something, that's not good by the way, every time you take the absolute value of a number, you're gonna get a positive number. Okay, so that's how you could get no solution. Okay, so to solve, we have the absolute value of 2x minus 1 is equal to 5. We're gonna split this up because we don't know if what's inside the absolute value is 5 or -5. We just know that after we take the absolute value, we get 5. So all of this could be 5, or it could be -5. So we're gonna have 2 equations that we have to solve. 2x minus 1 is 5, or 2x minus 1 is -5. And then we solve each one. So I'm gonna add 1, 2x equals 6, divide by 2x equals 3. Number 1. Okay, or add 1, 2x equals -4, divide x equals -2. We got 3, I got -2. On Math Excel, it's gonna ask you to separate your answers with a comma. Oops. Something like this, so you'll just list them. I don't really care how you do it. So 2 answers, and when you go to graph the solution set, so this is our number line. You're graphing the number 3 and the number -2. Okay, you don't need to do arrows or shading or anything like that, because it's not an inequality. We're not talking about numbers in between -2 and 3, bigger than that, less than that. No, we're just talking about 2 and 3, -2 and 3. Okay, so you just put like a dot and a dot, and that's it. Okay. Questions? You can check your answer by going and putting this back in here. Okay, and you should get 5 equals 5. What you do? Let's look at B. So B has some extra numbers. There's a number here, there's a number here. We gotta do some things and stuff in order to solve this before we go straight to this part right here where we split it up into 2 cases. So you don't want to do this until you know what the absolute value's distance is. We don't know that yet, because we have an extra 1 here, we got a 3 here, so we can't get there yet. So first, we're gonna add the 1. So we don't know how far the absolute value is. We don't know how far x plus 2 is yet, because there's a 3 there. So 3 times the absolute value of x plus 2 is 6 away. Now, under no circumstances do we distribute into absolute value signs. Okay, those aren't parentheses, right? Not parentheses. The distributive property says blah 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 equals blah 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 blah. Okay, these are parentheses. You're allowed to do that. That's called multiplication. We cannot do that here, even though these are being multiplied. Think of the absolute value sign as like a wall. You can't go through it. So you've got to stop and think, what else can I do to get rid of that 3?
Divide.
I can divide.
Whoa.
Okay, so you cannot distribute, and you will not distribute ever. Not now, not later. It doesn't change, ever. Got it? So our only option is to divide by 3. So I get the absolute value of x plus 2 equals 2. Okay, and then now I can split it up into the 2 scenarios. So I have x plus 2 equals 2. I have x plus 2 equals negative 2. Those are the 2 options. What inside could be. It could be 2, it could be negative 2. Here I get 0. Here I get negative 4. Questions? Are you sure? So under no circumstances are we going to do what? Distribute. Well, sometimes we can distribute.
Distribute with the lines, or absolute value.
Yes, don't distribute into absolute value signs, okay? Don't do that.
Silly.
Alright. Dot, dot, to dot. Alright, so I have some U try underneath. So it's a solution derived from the original equation that is not actually a solution of the original equation.
That's confusing.
Sometimes in math, we follow a specific set of steps out of, I don't know, habit or just because someone told us to. We don't actually think about what we're doing. We just kind of like, and then I do this, and then I do this, and then I do this. And as you're following this method, this algorithm for solving the question, you wind up accidentally creating new things. So you wind up creating solutions that don't actually satisfy the equation, okay, or even an inequality. So for example, if I put this on the board as an example and said, do math, you would split it up into two equations, right? One positive, one negative, and then you'd get x equals negative 5 and x equals 5. And neither one of these is correct.
Whoa.
Why? Because an absolute value couldn't have been negative 5 to begin with. So the real answer is no solution. Okay, but you created solutions using an algorithm that I told you you should do this all the time, right? But sometimes it doesn't work. Okay, so we have to do it to get through the problem, but sometimes you wind up creating things that are not actually solutions. That's what an extraneous solution is. So typically we see these extraneous solutions the most when we have another like variable in here, so like an extra x. That's when you wind up creating solutions that maybe shouldn't be there. Now, sometimes you'll get 2 solutions, they both work, it's fine. Sometimes one will work and one won't. Sometimes they both don't work. You just have to plug them back in at the end and see if they work. Okay, or if you see something like this before you're done with the problem, you could probably say, oh, maybe that's fine. So for this one, we have the absolute value all by itself, that's good. We're gonna split it up into 2 cases. So we don't know if 3x plus 2 is 4x plus 5, or if it's the negative version of that. Now, if I want to make this negative, since it's a binomial and has 2 terms, I need to make both terms negative. So we're going to have a negative 4x minus 5. So if it's more than one term, you have to make sure that you are negating the entire side. So you switch the signs of each term. If they're negative, make them positive. If they're positive, make them negative.
That's pretty complicated.
Alright, so now, solve, do math. Here I can subtract the 5 and subtract the 3x, and I get x equals negative 3. Here I can add 4x and subtract 2, and then divide, and I get x equals negative 1. So I got 2 answers.
That's it, right? That's all.
And now I'm going to check for extraneous solutions to see if they work.
Ooh.
Questions on how I got those things before I do that? Alright, so we're gonna check. When you check your answer, where do you plug the thingies back into?
The variables.
But where? Because there's variables everywhere.
To both of them.
This one?
No.
This one? This one? This one? This one?
Maybe.
This one? This one? This one?
Unsure.
Oh.
Neither?
You're trying to see if there's solutions to what?
The
original problem?
Yes, the original problem, the original
Oh
equation.
yeah, because one of them
That's
isn't.
where you need to plug them in. Some people accidentally plug them into like these, and then of course they're gonna work, because that's where you got them from, right? You created those equations and then you solved them, so of course they're gonna work there. Don't do that, that's dumb. Plug them into the original equation, okay? So you should be substituting in like a -3 here and a -3 here, and then do it again with -1. So, you have the absolute value of 3 times -3 plus 2 is equal to 4 times -3
These are.
plus
I
5.
feel like the hardest lesson so far is lesson 4.
You mean of the chapter?
Well, yeah, the chapter.
Sure, yeah, of the chapter, yeah.
Yeah, it's not very difficult. It's just the hardest lesson of the chapter.
Yeah. Alright, now when you check, you are checking to see if the right side is equivalent to the left side. Okay? Don't solve an equation. Simplify, simplify. Math, not math. Okay?
Okay. That makes
Alright,
sense.
so let's math. We have the absolute value of -9 plus 2. That's the absolute value of -7, which is 7. Okay, we're done mathing. Over here we have -12 plus 5, which is -7, which is -7. Are these equal?
No.
No. Meh. What does that mean?
That means the other one must be the
That's bad.
solution.
It means that the thing we just plugged in isn't a solution.
Uh-oh.
So we got a solution that is extraneous. What I would like you to do is just put a slash through the equal sign on the solution that is not actually a solution. Do not erase anything, just leave it all there, put a little slash through it. It shows me that A, you know how to do the problem the way I taught you to do it, and B, you know what an extraneous solution is. If you erase it all, I don't know that you didn't cheat off Drew. Wow.
Yeah, that's like it.
Don't do that. Okay. So just leave it all there, put a little slash through it. It's like an English class, right? When you write like a word like banana and it's spelled wrong and you're like, oh no, I don't want my teacher to see that. Do you do that?
Just a little bit.
Yeah, I would if I spelled banana wrong. Right?
Well, it's not banana.
So instead what you're supposed to do to keep it clean is just 1 strike through or 2 strike throughs so it doesn't look like trash.
It's actually a potassium.
In math
strike.
class we use pencil.
But I like to live dangerously.
Not that.
I like to live dangerously, so I use
So we can
pens.
erase. Yeah, no, don't do that. Okay. Let's go to the you try. Wait, oh, we didn't check the other one. Yeah, faggot.
Silliness is around.
Alright, so plug in -1 for x in the original equation. Okay, so I have the absolute value of -1, which is 1. Here I get -4 plus 5, which is 1. So that's good, right?
Yes.
Okay, so we're just gonna say that that's our answer and the other guy's not. We only have one answer here. Now, if you are like short on time, okay, and you don't have time to like plug everything in,
Yes.
yeah, no. You can half plug it in. So assuming you did everything right and you're just checking for an extraneous answer, right? Because you're so good at math, you know you didn't make any mistakes, you're just checking the solution to see if it's extraneous or not. What you can do is you can just plug it back into the right side, since that's the only side that matters anyway, and as long as it's positive, you're good. If it's negative, it's bad. Okay, now that's assuming you did the rest of the problem right. If you did the whole thing wrong, then it's not really gonna help you, okay? But that's like a quicker way to check your answer if you don't have time to do like all the math all the way through. You'll know that you got it right if it looks true-ish. See how this looks like close to true but not really? Okay, and this is true. That's how you know you did it right. So you did it right, but it's extraneous. Versus you just completely did it wrong would look something like that. Okay.
Then you know it's not from the
then you
math.
know that you did everything wrong.
It's from your own twisted imagination.
And you're a failure. Alright, so it looks like a compound
Substitute.
inequality with OR.
Subscribe to my YouTube.
Now, if it says that the absolute value of x is less than 5, what are possible solutions?
4. But it would be like open circle 5?
Open
And then
circle
the other
5.
way.
And in this way?
Yeah.
Forever?
No, 5. Open circle.
Okay. So all this stuff in here, what does this look like?
Empty void.
Yeah, garbage. Either. I'll take both. Okay, so when you solve an absolute value inequality, you are going to be creating a compound inequality. It's either going to need an or it's going to need an and. You have to know which one's which. So in general, if the absolute value is greater than, it's or.
So it goes both ways because it's absolute value.
Yeah. And if the absolute value is less than, it's and. So less than and, greater than or. Less than and, greater than or. Less than and,
Here, wait, let me write that down.
less than and, greater than
I'll just say less than and.
or. Less than and, greater than or.
But no, isn't that opposite?
Because think, if the absolute value is greater, then you're looking at like the extremes. Stuff,
But look, that one says
me
if x,
and me.
if x is greater than 5, it's or.
But if it's less than, they're gonna wind up going into each other.
So it's and? So less than is and?
Yeah.
Less than and, greater than or.
Oh!
The question isn't gonna say and, it's not gonna say or, you're gonna do math, and then at the end, you have to put in an and or an or.
It's like finding the theme measures.
Did you just like language arts too much?
Indeed. Alright, so we have the absolute value of 3x minus 2, plus 2, is less than 7. Now before we do anything fancy, we're just gonna subtract the 2, so that our absolute value is all by itself. So I have the absolute value of 3x minus 2 is less than 5. Can't think of that. This is a number line. 3x minus 2 is here and here, and it has to be less than 5, okay? So we're talking all of these numbers like 4, 3, 2, 1, etc. That is the realm or the solution set, okay, for 3x minus 2. So this chunk right here, these numbers are from here to here. These are numbers that are, what, bigger or smaller than 5?
Smaller.
Yeah. Okay, and then this chunk right here, these numbers are what compared to negative 5? Bigger. They're bigger than negative 5. So when you go to set up your two inequalities, aka your compound inequality, you're gonna write 3x minus 2 is less than 5, and 3x minus 2 is greater than negative 5. And that's the only way it's gonna go.
That's it, that's all?
Well, and then you do math.
Dang.
Yeah, and you gotta solve both inequalities. So you're switching two things. You're switching the inequality sign and you're switching the sign of the number.
That's gonna be a fraction.
Is it though? Let's find out. Alright, so we're gonna add 2 when we get 3x is less than 7. Oh, fraction. So, and then we're gonna divide, we get x is less than 7 over 3. You can leave it as 7 over 3, as long as it's simplified. Okay, it's about 3 1/3, 3.3 repeating. Wait, just kidding. 3.3 and 2. No. Oh, I was right the first time. 2.
Okay.
2.3.
Did I say 3?
Yeah.
I'm down.
2.3 repeating.
2 1/3 or 2.3 repeating. Dum dum. Okay, let's do this one. So we're gonna add the 2. And that's gonna give us negative 3. Oh, no fraction here. X is greater than negative 1. Okay. Now, I'm gonna graph this on a number line. We have, let's say, -1 is here, 7/3 is here, and I guess 0 is like somewhere in here, but slightly closer to 1. Okay, so we want numbers that are less than 7/3 and greater than -1. Okay, where is the intersection?
-1 to 7/3.
Jinx, you
Right, it's right in here. So your final answer is gonna look like a compound inequality, like so. Smushed together like that. When you put inequalities together like this to create compound inequalities, you gotta make sure of a few things. Number 1, these are always less than signs, okay? Never greater than signs. Number 2, the smaller number goes on the left, the bigger number goes on the right. Number 3, it makes sense, okay? It has to make sense. If you can't put less than signs and smaller, bigger, it doesn't make sense. So for example, this doesn't make sense, right? Doesn't make sense. If you have to do this, that might not be what your answer is supposed to be, okay? If x is smaller than 0, or smaller than 5 and bigger than 10, you have no solution. You can't be smaller than 5 and bigger than 10. Okay, so you would have probably had to write it like this. It was probably an or question that you turned into an and question. If it actually was indeed an and question, it would be one of those special ones that's no solution. Okay? You never want to do this. Always smallest to greatest, and they should always be less than signs. So if you can't do it so that it makes sense, then something else is wrong. Okay? Now we can do it here, so that's why I did it. Questions?
Understood.
Let's do another one. Alright, what would I do first? Subtract. So I have 4 times the absolute value of 2x is greater than or equal to 10.
Ooh, I know what you do next.
What?
You would divide.
Yes, you would divide.
I'm so smart.
You under no circumstances do what? Distribute. Yes, or in this case even multiply. Don't do that either. In this question you would probably get it right, but you'd get lucky. So you get 10 over 4, which is 5 over 2, or you could put 2.5 if you want. Okay, and then we're gonna have 2 inequalities. We know that 2x has to be greater than or equal to 5 over 2, or 2x is less than or equal to negative 5 over 2. So I switch 2 things. I'm switching the inequality symbol and the sign of the number. So you're switching the sign and the sign. Same thing. And how do we know it's or? But I did that. How do you know?
Oh, because it's greater than.
Because it's greater than.
Yes.
Right here. So think this way. If it's pointing to the right, then it's going to go like right and left. That's an or. If it's pointing this way, then the other end has to go this way. They're going to go into each other.
The other kids.
They're always going to go like opposite directions. Okay, let me math. How do I solve this?
Divide.
I can divide by 2 or
Multiply by
Multiply by reciprocal.
multiply by the reciprocal. Okay,
times 1/2.
so the reciprocal of 2 is 1/2. I get x is
Oh.
greater than or equal to 5/4. Okay, or 1.25. Do the same thing over here. You're going to get x is less than or equal to negative 5/4. Let's look at a number line. And 5/4 is 1.25. So we got x is greater than or equal to 5/4, or x is less than or equal to negative 5/4. Okay, which makes sense because of the word or. But if we put the word and in there, it doesn't make sense. If you were to try to put this, like write it like we did here, we would probably do this. Okay? This doesn't make sense. Okay, because the bigger number's on the left and the smaller number's on the right, and that doesn't make any sense. Okay, and if you go like this, it's lying, because you didn't get that x is bigger than -5/4. So that doesn't make sense either, because you're telling me that the answer is not that thing. So, don't do that. We just do this, we put an or in between it, and we call it a day. That's our answer.
Really? Oh.
Then you graph the solution set if you want. With inequalities, there's special cases with these absolute value inequalities as well. So, what would I do first here?
Ooh, we're doing more.
I would subtract.
Are these a separate section? They look like the same.
No, they're the same.
Yeah. That's what I thought.
Okay.
They look easy.
So then we would split it up. We would do x plus 1 is less than -2.
Wait.
X plus 1 is greater than or equal to 2.
This isn't
We
long.
get x is less than or equal to -3.
We're going
X
pretty
is greater
speedy.
than or equal to 1. And what word do we put in between here?
And.
And.
Oh, I'm so smart.
You're going pretty speedy. Could you slow down for a second?
I'm kind of doing that on purpose.
Whoa.
Oh no, it's Aaron.
Aaron, what's he doing
Stuck
here?
behind the door.
What are you doing here?
Okay. So we have all numbers less than or equal to -3 and greater than or equal to 1. What numbers are less than or equal to -3 and greater than or equal to 1? None, right?
No.
There's no intersection here. Do you see intersection? I don't see intersection. No intersection. If there's no intersection, there's no solution. We just solved a problem that we shouldn't have solved. Do you know why?
You started with that -2,
Yeah.
and it's just not right.
We started with something that was in its nature unsolvable. Okay, there's nothing I could possibly plug in for x where this absolute value is going to be less than a negative, because no absolute values are less than negative numbers, because none of them are even negative to start with. Okay, so at the very least, you would have to have a 0 here. Okay, now if it's a 0 and there's no or equal to, I can't even have that. That's bad.
Let me guess. The next one's all
Okay,
real numbers.
so at the very least, it has to be either less than or equal to 0, or it has to be something bigger than 0 over there. Now if it's greater than, is that okay?
All real numbers.
Yes, so why is it all real numbers?
Well, anything you put in is gonna be greater than -2.
Exactly, anything I put in is gonna be greater than -2, because all absolute valued things are bigger than -2, because they're all positive. Okay, so that's the difference here. You could put the absolute, or the all real number symbol, you can write all real
Whoa,
numbers.
I drew a good one.
Or you can write infinitely many solutions.
How about all of them?
All of them.
How about all of them?
How about 2 of them?
Okay, what you don't want to do is solve and then not realize that that was a special case.
Now can we do the math Excel for